Dr. T, and welcome to my office. So today I'd like to talk about polymers. So polymers, as the name might suggest, are going to be molecules made up of many small molecules. Of course, poly meaning many. So polymers are going to typically be absolutely gigantic molecules, some of the largest, if not the largest molecules on Earth and in existence are polymers. And the way they come to be is they start out life as monomers. The word mer basically means molecule, so monomer would be one molecule. These are small molecules. When I use the word small molecule, basically I'm using it to distinguish something that has, a few atoms, dozens of atoms, not something that has tens of thousands of atoms. So monomers are going to be small molecules, and then those, through one of a couple of different types of chemistry, are going to be able to be stitched together. If you stitch, say, two monomers together, you get a dimer. Three, you get a trimer. If you stitch a few, and different sources will disagree on how many a few is, but let's say, half a dozen to a couple dozen monomers, you get what's called an oligomer. But if you start sticking together hundreds, thousands, tens of thousands of monomers, you get a polymer. And this is how we can make very, very large molecules. You make small molecules and you just start sticking them together, very much like, building something out of Legos. It's simple parts, but you build them out and you flush it out. Now, polymers and their constituent oligomers, dimers, trimers, those kinds of molecules come in several different flavors, and it really depends on the nature of the monomer. It really dictates a lot about the polymer. So the first question we can ask, is it a single type of monomer? If so, it's a homopolymer. And a lot of the plastics we deal with are such homopolymers. If you look at your water bottle, its monomer is ethene, and those stitch together to form a very long carbon chain. But it's only one type of molecule. Now, there are other polymers, though, that start out with a blend of monomers. If you look at nylon, like the shirt I'm wearing, typical nylon is nylon 66, and that comes from the fact that it has two different monomers, both with 6 carbons in length. The numbers will change depending on the type of nylon. Most common is 66, but you will find other different versions of nylon in other uses, such as, say, brake lines or windshield wipers. These are known as copolymers. Now, you could have, as in the case of nylon, an alternating kind of A-B structure. Alternatively, it could just be a jumbled mess, and they all just kind of stuck together. You got clumps of this one, clumps of that, etc. Now, the other question we can ask fairly straightforwardly with polymers is, do the monomers attach on two ends or more? They have to attach on two ends. Otherwise, you can't form a long chain. A Lego brick, if you look at it, has the kind of the pokey end or the little bumps, and then it has the bottom end where the bumps go into. So you have two ends on your Lego brick. But we don't have to have two ends. We can have 3, 4, or more. If you only have two ends, then you're going to create long chains, and we call this an unbranched polymer. However, if your monomers can attach on multiple points, and therefore allowing you to fork off in branches and whatnot, we call this a branched polymer. The physical properties of these, of course, are going to be very different because instead of long, thin spaghetti noodles, you have bottle brushes and ferns and trees. We see this heavily in polymers such as glycogen and starch that I'll talk about later when I go more in depth into the carbohydrates. Another way of looking at your polymers is, well, how did you make them? What was the underlying chemistry to manufacture this particular polymer? Is this a addition reaction where you take, say, a double bond and another double bond and boom, you turn them into single bonds and now they're all stuck together? This is the aforementioned ethene. In that case, if I want to make polyethylene, which would be number 1 or number 2 plastic, depending on exactly how I manufacture this, then I take a bunch of ethene, which is C2H4. It's got a nice double bond. I do a radical reaction, and then that double bond forms single bonds with 2 other ethenes. And boom, I get compound and this nice long unbranched chain. However, there are other ways of doing this, and another common approach is known as a condensation polymer, such as nylon. In this case, a small molecule is released. Commonly, this is going to be water, but it doesn't have to be water, depending on the actual chemistry of your particular polymer. But as they react, you have a few atoms that need to go away in order to form the bond, and as they do, that is the small molecule that you could then say, condenses on the outside of the container, hence the condensation of the name. Obviously, depending on exactly your chemistry, is what's going to happen to that small molecule. The individual reactions, do impart differences into the nature of the final product, although usually that is not one of the largest considerations. Now, with polymers, the chemistry actually kind of takes a back seat to some of the physics and the physical properties. So for that, I'm going to wait until another video. So with that said, have a wonderful day, and I'll see you in the next video.